Hello everyone. Hi, this is Rishabh Pandey and I am a physics faculty at askIITians. Today we'll be discussing the fourth lecture of Human Eye in the Colorful World. Before this, we have already done 3 lectures. In this, we'll be talking in depth regarding the dispersion and the deviation of light by a prism. Right, so we'll be understanding each and every concept in detail. Like in the previous session, those who have not seen that, please go and watch it first. In the previous session, we just spoke about the basics of the prism, right? So this is the normal, there's a light, and so there used to be an angle of incidence, and this used to be an angle of refraction, and then this light, depending upon their wavelength, the speed varies, correct? Speed varies, and due to this variation in the speed, they basically split into a band of 7 colors, as you can see, correct? Viv, Geor, I hope everyone knows this thing, correct? So we spoke uh, little things of the deviation and all these stuffs regarding the prism. But yes, now we'll be starting with the in-depth review, that how the prism works. And as if you could remember, there used to be an yes, this used to be an angle of prism. I'm just trying to give you a brief snap out of what we did in the previous session. This used to be an angle of prism, and then say this is a kind of normal, and then with this the angle of r dash. This used to be r dash, and this when the rays goes like this, then this used to be I dash, or you can also call it as emergent angle, and the if these normals are joined together, then they form an angle that is called as angle of theta. And obviously, this say this is the ray which was supposed to go like this, but it went like this. So this gives you the angle of deviation. So we discussed all of these things in the previous session. Today, we are going to talk about deviation of light by a prism. Well, there are various factors on which the deviation of light basically depends. Say, for example, the wavelength is one of the key factors, of which in the previous video I just gave an idea that what is the deviation and how basically it occurs. I'll try to recollect that. Say, light are made up of different wavelength. Light are made up of different wavelength, and the color of the light is basically due to their wavelength. See, you can see this color to be red. That means the wavelength which it is emitting gives it a red color. You can see this color to be black. That means it's giving a light of black radiations. है ना? But so point is that every color has their own wavelength. है ना? Some are like for one particular color there are different shades. है ना? So if you go to the higher shades, the darker shade, that means it has a higher wavelength. If I go to the lower shade, that means it has a lower wavelength, right? So the wavelength is the key factor in deciding the color of that, the shade of that particular color, the color of that particular light, and also the speed. And so wavelength basically decides these two factors, that is color and speed. These two factors are governed by wavelength of the light. And there's a visible region where the light is visible to us, and a particular light going beyond this visible region. It's called it's not visible to us. It's called as ultraviolet radiation, UV radiations, and a particular light which is going below this visible region is called as infrared radiation. Like for example, the examples of infrared radiations are radio waves, and UV radiations are alpha radiation, beta radiation, gamma radiations. All of these are the UV radiations. Like for example, I just try to give you an example that I have got a dongle over here, dongle setup, and this laptop, iPad, mobile phone, everything connected by using that dongle, correct? There's a ray of Wi-Fi entering into this laptop, there's a ray of Wi-Fi entering into the mobile phone, there's a ray of light entering into the pad. Point is that are those ray of light visible to me? Probably no, right? That means those rays of light does not lie in the visible region. अगर मेरे पास वैसी आंखें होती तो ऑब्वियस सी बात है कि फिर मैं उन सारी चीजों को ज्यादा बेहतर देख पाता। मैं देख पाता, हाँ देखो यहाँ से वाईफाई आ रहा है, देखो यहाँ से सिग्नल जा रहा है, see there's a satellite which is receiving the signal. I could have seen that. But since my eyes, or a human eye, I'd rather say that the human eye is not capable of looking to these things, these wide ranges. So that is why they they are not visible to us. That means they lie beyond the visible region. They don't lie in the gap of this visible region. Now, when basically a light enters, basic point is that white light is a combination. White light is a combination. White light is a combination of 7 colors. White light is a combination of 7 colors. And every color has their own wavelength. As I said earlier, that the color is decided by the wavelength itself. So every color has their own wavelength. Color have their own wavelength. And the speed of the light also differs. And the speed of the light also differs. Speed also differs due to the wavelength. And the speed of the light also differs due to the wavelength. So generally what happens, that when a white light enters, it's traveling in air, and they all travel almost with the same speed. But as soon as I change their medium, they split into a band of 7 colors. That means they all go like apne apne raste, and they part their ways. So point is that I can have another conclusion over here, that in air or vacuum, they travel at same speed. That is why there is no dispersion of light taking place. But as soon as I change their medium, like for example, I'll tell you an example. Say for the case of a rainbow, there will be few drops in the cloud remaining like this. These drops acts like prism, and as soon as a ray of light from the sun enters over here, strikes this, the medium changes, and due to the change in medium, they deviate in the combination of Vibgyor, as I know. Correct? So this dispersion of white light is basically due to the concept of the wavelength. Am I clear? Wavelength is what? Wavelength is like this is basically class 12th topic that is given by basically we say that light is of dual nature. Light is of dual nature. That is particle as well as wave. And depending upon the situation, light behaves either as particle or as wave. Let me give you an example. Your behavior in front of your friends and in front of your parents differs. Absolutely. I mean, you cannot have the same behavior in front of both of them, right? Similarly, light is also very smart, and it looks at the situation and then it decides that what kind of behavior it has to show, and then depending upon the situation, it shows its behavior. What I'm talking about here as the wavelength is a part of the wave theory, and it's a part of the wave theory. If I tell you the history of this, basically Newton wrote a book that is called as General Optics. And he gave this name optics, and he wrote, instead of C, he wrote it as K. So that's why he gave this name, and that's how we study in geometrical optics, wave optics. This name of optics was given by the Newton itself. He said that light behaves as particle, and those particle were given the name that is corpuscles. Corpuscles, right? He said that light behaves as a particle, and those particles are called as corpuscles. Everyone agreed, because at that point of time, like, Newton was such a big name that anything said by Newton was like the truth, the ultimate truth. So Newton said that light is like a particle, and these particles are basically a composition of smaller particles that is called as corpuscles. Everyone agreed. But then another scientist came whose name was Heisenberg. Heisenberg. He performed an experiment, that is Young's double slit experiment. He performed an experiment of double slit. You just write it as slit. And he said that these phenomena are only possible if light behaves as wave. Now you just try to understand. Newton didn't perform any experiment, he just gave a theory. Heisenberg performed an experiment, right? And after performing an experiment, obviously, who was in the winning situation? Heisenberg, because he performed an experiment. So it was like clear that light is a wave, light is not a particle. But the real problem arrives over here. Another scientist whose name was Maxwell performed black body radiation. Black radiation. I'll just write it as black radiation. And he said that this phenomena is only possible when light behaves as particle. Look. This is where the real problem started, basically. Now light was showing the behavior of wave, and light was showing the behavior of particle, both the situations, right? Ultimately, it was concluded. I'll just remove this thing from here. Yes. So ultimately, it was concluded that light shows dual nature. End of the story. Dual nature. It depends upon the situation, that what kind of behavior it has to show, right? So when I'm talking about the dispersion of light, or I'm talking about the deviation of light by a prism, it is due to the wave phenomena, right? The wavelength has something to do over here in this case. Am I clear till this part? Sure. Moving on, as you can see over here, this is the phenomenon of deviation taking place, that a light light is trying to enter into this region. A light is trying to enter into this prism, and after entering into the prism, it deviates into 7 bands of color, as you can see. It, see, light, say it's a white light. White light. Since it was in the air, so it all were traveling at the same speed. But as soon as the medium changes, it's like the medium changes. It deviates, and deviates so that it deviates into different colors, as you can see. It deviates into different colors depending upon the situation and depending upon their wavelength. So this deviation is taking place due to their wavelength. Correct, as I said earlier. So if I say that a light is reflected as it enters a material with refractive index greater than 1, you must have studied refractive index in the previous chapter, that is light. That refractive index is mu is equal to speed of light in air upon speed of light in a particular medium. So say if I am taking here as a glass and I'm taking a glass over here. So the medium is changing. That means if it is traveling with a refractive index greater than 1, if this is the case, then in that situation light is deflected twice in a prism. The sum of these deflections is the deviation angle. We did talk about it earlier, that say here, this is the angle of deviation. This was like deviation 1, the deviation 2, and sum of these two deviations, deviation 1 plus deviation 2 will give you the total deviation. So this is how we calculate this. When the entrance and the exit angles are equal, the deviation ray passing through the prism will be minimal. That's a different thing. That's a phenomena of minimum deviation. We'll talk about it. But you should be clear with this, that whenever white light enters into a prism, it suffers deviation twice. Here, the red will suffer the minimum deviation. The red will have minimum deviation, minimum. Whereas violet will have the maximum deviation. Violet will have the maximum deviation. And on what factors that the deviation basically depends? It depends upon the prism angle. Another point. Prism angle. This decides the angle, the power of deviation, power of deviation. That how, by what angle a prism can deviate, power of deviation. And this is governed by the material of which the prism has been made, depending upon the material. And then depending upon the material, the prism angle basically depends. Like for example, glass prism and plastic prism both have different prism angle, or basically they have different power of deviation. Similarly, if I move forward, uh, start a discussion about this minimal deviation, minimum case of minimum deviation. Say, before that, chalo theek hai, we'll get back to this later on. Condition of minimum deviation. What's the condition of minimum deviation? Basically, the condition of minimum deviation has been given by a graph. Say, this is a graph of deviation and angle of incidence. A graph between the deviation and the angle of incidence. And the ultimate results looks like this. Looks like this. This is the point of minimum graph of minimum deviation. If you look closely over here, basically the deviation is minimum. Again lost the pointer. Achha, yeah, it's here. The minimum deviation is basically over here. This point has a minimum deviation. Correct. As you can see, this point has a minimum deviation of all. Right. This is on the y-axis. So on y-axis, this has the minimum value, and I can say that this is the situation of minimum deviation. And this is possible. This is possible if angle of incidence is equal to angle of emergence. If the angle of incidence becomes equal to angle of emergence, in that situation we'll have the minimum deviation. Am I clear till this part? Yes. Do I have a formula to find this? Yes. So I'll just write it as, we'll just write it as condition of minimum deviation, the first one. The angle of deviation of ray from the source, from the secondary sources, from the source from the second, I mean what I'm doing, from the second second phase equals the angle of incidence from first phase right? That means angle I should be equal to angle I dash or angle E, and if this situation has been satisfied, right? The second is refractive index, that is mu. In this situation, if I want to find the angle of minimum deviation, this will be the formula, that is sine A plus minimum deviation divided by 2, the whole divided by sine of A by 2. By using this formula, I can find the angle of minimum deviation, right? Where I hope everyone understand where A is basically the angle of prism, correct? Angle of prism. Delta M is minimum deviation. True. Then we have mu, that is basically the refractive index of the material, of the whatsoever material we are using it. If I want to find the refractive index for that material, like for example for glass it's √2, so you should have these small things clear in your mind, right? So this is the situation of minimum deviation, where this will be your formula. Correct. Now if I talk about deviation of light by a prism, this was a light incident beam, we discussed this thing earlier. This is angle I along with the normal, and if I connect these two normals, I'll get an angle that is theta. This is angle of the prism, it has been taken for this situation, it has been taken as 60 degrees. It's just an example in this case. And then this light was supposed to go like this, but it went like this. That means this will be the angle of deviation, and the angle of deviation has been given by deviation 1 plus deviation 2. We even derived the formula for this in the previous video. I hope everyone remembers this. This will be the angle of emergence, that angle at which the light ray is basically emerging out of the prism. And these are the various points, the angle of deviation. What you need to remember, the important angles are angle of incidence, angle of refraction, angle this is like R dash, this is like R dash, and then angle of emergence or I dash. Also the angle of the prism. So these are the various angles in the prism which needs to be considered, right? So you should have a clear concept of all these angles in all the cases. We even did a numerical based on this in the previous video, right? If I move forward, this is the case of deviation of the light by a prism. If you look at this question, which ray is least deviated by a prism? Least deviated means, say if this is a prism, although I'm that bad with the drawing, but please cope up with me, expect so, right? Say this ray of light was supposed to go like this, and then it got deviated into this. So say the first, second, third, fourth, fifth, oh my god, sixth, seventh. So this, the first ray, this is like wave gear. So this red light is almost not deviated, although this is the fault of the painter, but still, red light is the least deviated, and violet light is the maximum deviation. We did even wrote about it. I think everyone is clear with this, that the red ray will be the least deviated by the prism. Am I clear? And this will be the least deviated by the prism. Next, the dispersive power of a prism depends upon. We even talked about this, and it depends upon the material of the prism. That means from which material the prism has been made. I hope I am clear till this part. See, basically, what we did discuss today was the deviation of light by a prism. The wave theory. The wave theory. This is, you can say, a kind of wave theory. We just try to introduce. I try to introduce the wave nature of the light to you, the wave nature of the light, who gave what kind of laws and why they were not valid, and what all conditions we have and what all impact we have. The wavelength, how does really the wavelength basically affects us. We did hold a discussion regarding this. Then deviation of light by a prism from one medium to another medium, correct? Then deviation of light by a prism, the various terminologies used in this case, the condition of minimum deviation, which is like quite important thing, and then there are few numericals. I hope I was clear till this part. Please make sure that you are performing numericals based on this.